Hello everyone, it's Mrs. Thomas. Today is Wednesday, January 10th, and this is kind of the official part 2 of our 5.11 momentum and collision worksheet practice that we did today in class. So we spent a lot of time together. We were able to take a look at what momentum is. We were able to look at the formula for momentum. And we also did a lot of practice involving objects in motion, finding what their momentum is, and then also comparing objects in motion with different masses, like a St. Bernard and a Chihuahua. So we got a chance to do that in class. If you have questions about those types of problems, you can view our initial recording from class on today, January 10th. However, we did not get a chance to talk about collisions. We ran out of time, so I wanted to make sure to post this today. As you know, collisions are those interactions we have in life that go crash, bang, or boom. It's when things bump into each other. So if you were here in class today, I'm sure that you would share your idea and tell us about a time maybe that you played sports and you collided with another player. That can really hurt. I hope this isn't true for you, but sometimes folks get into car collisions in which their vehicle hits another vehicle. So these are all examples of collisions. So today what we are going to do is look at the physics of collisions. So we are going to use what we know about momentum and use the formulas that we've learned together about how objects are in motion and what happens when they collide, so we can predict some information about their motion. So most importantly, when objects collide, they don't always do the same thing. So when objects collide, they can do one of these things. They will either bounce off of each other and continue to move separately, or those objects will stick together and continue moving as one object. So today we're going to take a look at an example of both of these types of problems. So we'll begin today with a collision in which things are sticking together and moving as one object afterwards. So today in class we were able to review 4 different formulas that we use to calculate momentum of objects and predict some information about their motion. But because today we're talking about collisions, we are looking at the equation that uses 2 different objects. So this equation says m1 times v1. That means the mass of object 1 times the velocity of object 1. When we add that to m2 times v2, meaning the mass of object 2 times the velocity of object 2, it is going to equal the sum of both of their masses, the mass of object 1 and object 2 added together, times the velocity of those objects as they move as one thing. So this means that our momentum is conserved. We talked about that in class as well. So the momentum those 2 objects had as individual things is going to be conserved, which means it's going to also affect how those objects move once they stick together as one object. So the first part of our equation tells us information about calculating momentum for those objects individually. And the second part says those 2 masses will be added together. It's like it's moving as one mass at a certain velocity because they are sticking together. So let's look at an example of this. Our story says Martha fires a .02 kilogram bullet at a block of wood that has a mass of 0.3 kilograms. The wood block initially is at rest. The bullet is traveling 200 meters per second when it hits the wood block and sticks inside it. Now, the bullet and wood block move as one object. That's really important because it's telling us to use the formula for things that move as one object. They're sticking together. So this question is asking us, how far are they traveling now that the bullet is stuck inside that wood block? So let's check this out. Again, we have our formula ready underneath here to give us a guide to help solve this problem. So what I need to start doing is figuring out what information I know. So again, m1, v1 is the information for the momentum of object 1. So what I did is I kind of made pictures and I helped us organize what object 1 is and what object 2 is. So for this example, I said object 1 is the bullet. So I need to start finding this information. The mass of object 1, the mass of the bullet is 0.02 kilograms. I see that in my story. So my mass is 0.02 kilograms. My velocity of object 1, that's what V1 stands for, would be what? How fast was our bullet traveling? It says the bullet is traveling at 200 meters per second. Okay, so that is the initial mass and velocity of our bullet. Now we'll move on to the second part of this equation, and it's asking us about the mass and velocity of object 2. And we are calling object 2 the wood block that bullet is being fired at. The mass of the wood block is, the mass of the wood block is 0.3 kilograms, because it says the block of wood has a mass of 0.3 kilograms. And the velocity of our wood block is not spelled out with a number. But if I read carefully about the wood block, we know its mass, but it says the wood block is initially at rest. That means it's sitting there like a target. It's not moving at all. If an object is at rest, it's not moving, it's not going to have a velocity. We consider it to have a velocity of 0 meters per second. Because if you're not moving, you are covering 0 meters per every second that you're in motion for. In this case, the velocity of the block would be 0 because it's at rest. So what I'm going to do now is start to fill in this information using our equation we're given, because I've found all my variables and we are looking for v velocity. So I'm going to use a text box and start to fill in the information that I know. So m1 in this equation is 0.02 kilograms. I'm going to multiply that times v1, which we see is 200 meters per second. I'm going to add that to m2, which is 0.3 kilograms, times v2, which is 0 meters per second. That left side of the equation is equal to both masses added together times their velocity. So the masses of these objects are 0.02 kilograms plus 0.3 kilograms times v, because v is that number we are trying to find. We don't know what v is. So now that I have taken my equation and I filled in the information that I found in place of those variables, I can start to solve it. So I know, using another text box to show my information, I can use a tool to start to solve this. If I take my calculator, my tool that helps me stay accurate as a scientist, I can take the values of 0.02 times 200, and that gives me a value of 4 for this first portion. And the next part of my equation, I'm taking a value of 0.3 times 0. We know anything times 0 is going to be 0. That's pretty easy. Let me move on to the right side of my equation. I'm seeing this value of 0.02 plus 0.3, and that gives me a total of 0.32. So what I can do now is start to solve for v velocity, because I have simplified this equation. I have started to work on these numbers. So what I am left with in this situation is 4 is equal to 0.32 times v. If I use my algebra skills, I know I have to do the opposite operation over here in order to get v by itself. So right now we are multiplying 0.32 times v. Well, in order to get v by itself, I have to divide both sides by 0.32. So once I do that, I am going to cancel out that 0.32 on the left. So I'm just going to be left with v, and let's see what v equals. I can see I'm going to take my value of 4 and divide by the 0.32 that's on the other side, and I get a value of 12.5. So when my question is initially asking me how fast are they traveling, I'm considering how fast are the bullet and block traveling now that they're stuck together. Well, we've used our equation, our knowledge about the conservation of momentum, and we can see that the block and the bullet together will be moving at a velocity of 12.5 meters per second. That's really fast. That means for every second that goes by, that block and bullet that are now one object are going to go flying by 12.5 meters of space. That is a quick speed. So I hope this helps you understand our first collision problem involving objects that stick together. The second type of collision that is possible is objects that bounce off of each other. So what we get to do for this is to look at a similar equation, but it's just comparing the momentum of those objects before and after. So just like we did similarly, I'm going to start looking at my word problem and finding the information that we need. Because I see that M1, V1, M2, V2, I'm going to assign my objects a number so I don't get those confused. There are lots of values and units in my word problem, so my first step is always to organize. So I'm going to put a picture, I might label object 1 as the ball, and I'm going to start to find this information. The mass of my ball in this story problem is 7 kilograms, just like you can see in the first part of the sentence. My velocity before the collision of the ball is 9 meters per second. And my velocity of the ball afterwards is what I'm trying to find, because the question asks me, how fast is the bowling ball now traveling? So we're looking at this bowling ball and this pin that are colliding and bouncing off of each other. We want to know how fast that ball is traveling. So we'll continue to fill in the information that we know from our story. The pin has a mass of 2 kilograms. The velocity of the pin before the collision is 0 because the pin is sitting there. It's a target. It's just waiting to be collided with. So it's at rest. It's considered to be 0. After they hit each other, it says the pin goes flying forward at 14 meters per second. So now I have all of the information that I need except the velocity of the ball after. So I'm going to start to plug in the information that I have and to show what I know to calculate the velocity of the ball after the collision. So the mass of the object 1 is 7 kilograms. We're going to multiply that times its velocity, which is the answer we don't know. We're going to add that to the mass of object 2, which is 2 kilograms, and multiply that times the velocity of object 2 beforehand. That is going to be 0 meters per second because it is at rest. Oh, goodness, I made a mistake, and that's important for me to correct. We are looking at the mass and velocity of the bowling ball before the collision. We know how fast that ball was going. The velocity before was 9 meters per second. So let me correct that. That's important. I'm glad I'm making mistakes for you in a recording to show that I'm not perfect and you shouldn't be either. Keep working hard on this. So I can take a look now and see that the ball afterwards has the same mass, of course, 7 kilograms, and that is going to be multiplied times the velocity afterwards. That's what we don't know. So we're going to keep filling in the information that we know about these objects and then solve these all together. So at the end of this equation, we are able to finish up our multiplication. So we're going to take, let's see, we're going to take our individual values and start to add them together. So 7 times 9, of course, would be 63. We're going to add that to 0 to give us the right side of equation, which is 7 times v plus 28. We're just following those individual pieces. So you can use your algebra skills in this case to subtract 28 from both sides, which gives you 35. 35 divided by 7 is 5. Our total answer